Hey Valley Middle, welcome to lesson 3.7 AB. Standard lesson today, review, video, 1 through 9, guided, and then you got skill sheet 3.7 AB. There's a video tutorial that'll help you through that too. I'm not going to lie to you, kids find this to be a tough target, but I've spent a lot of time retooling the lesson. I think it's good. I think it's really good. All right, let's get going with the review. Here we go. Find the perimeter and area of that rectangle, balance and solve. These are the three problems. Maximum of 5 minutes. Go ahead. Okay. Well, you just pop x in there. That would be 2 times. Literally, you take the x out and you put parentheses in and put it like this. That becomes 20 on this side, and then half of x is going to be half of 10. Same way, and that's going to be 5. So that's going to give you 20, 40. And the two 5s together make a 50 perimeter, 50 units, not O's, 50 units. And the other one, it's going to be, then it's going to be 5 times 20, which will give you 100 square units. So 1.6 AB, just substitute in a value for a variable. That's all we're doing here. Balance and solve these three. This one's IMS 5. Make sure you've got the line separating it. Make sure you got your equal signs lined up. Make sure you show the cross out. Here's a two-stepper. Looks like I forgot, or one of my lines got deleted there. Let me just put that other line in there, so that's in. And a division problem, which you solve by multiplying by 0.5 on both sides. Get m equals 12.5. Again, check out the equal signs are all lined up. Remember, you need to use this graphic organizer, the railroad tracks, on that. Hey Valley Middle, welcome to a math video. Tonight we're going to be looking at the relationship between lines, equations, and tables. Let's go ahead and start with our just for fun question. Who is Stanley, Kirk, Burrell? I'll give you the answer to that at the end of the lesson. Officially tonight we have two, they sound complicated, but they're really not that complicated. Here are the two targets. I can graph data to show the relationship between tables, graphs, and equations. I can complete function tables and identify coordinate pairs in that table. Really what we're looking at is, can you look at a set of data on a table and can you graph it? That's number one. And number two, do you understand how an equation, a table, and a graph work together? Do you understand the relationship between them? I think we can do that tonight. Let's take a look at a real life problem just to kind of start with. First of all, many of you know that I plow snow, and so this little function table I've made here can help me figure out how much or how many hours of work I'll have to do for a given snowfall. So if I have 1 inch of snow, I generally have to work 1.5 hours. And if I have 2 inches of snow, it's about 2.5 hours. 3 inches of snow, 3.5 hours. And so one begins to ask, well, what if you have 0 inches of snow? What if it doesn't snow? Well, I still got about a half an hour work because I still have to get the truck ready, put the plow on, and I'm up checking the weather and things like that. So, 0 hours of snow is still a half an hour work for me every time it's in the forecast. So, I've got this little table here. What's really going on? Well, really, the rule is whatever the x is, we're going to add a half to it. So, it's x plus a half or x plus 0.5. Now, we can take these x values and y values here and just put them into ordered pairs, like I have here. I just took them, set them next to each other, and put a comma next to it. Now you recognize that as an ordered pair. And we can graph those. Here's this first one here. And I'm going to close these just so that you get used to looking at them right from an XY chart. I'm going to graph 1, 1.5. So here, grab my point. Always start at the origin. I'm going to go over 1 and up 1.5. Grab another one. I'm going to start at the origin. I'm going to go over 2 and up 2.5. And I'm going to grab it, oops, and do the next one. Let's go over 3 and then go up 3.5. And there's nothing magical about that. I just went the first value. I'm going to go left or right on. I'm going to move forward or back. And the next value, I'm going to go up or down. This is your x and your y coordinate. So put a line right on there, and I could use that line then to predict other things. Like I could look and say, well, if I get, 5 inches of snow, I'm going to have 5.5 hours of work to do. All right. This is an example of how these work together. The third piece is the equation. Well, we already know what the rule is. The rule is it's whatever x is plus 5. All the equations, you just say that y is equal to that. Y is equal to whatever x is plus 0.5. So you've got the table, you've got an equation, and you've got this graph. And all three of these work together in unison, and they really have this relationship. I mean, if I had just this graph, I could make this table and I could write this equation. If I had this equation, if I just had the equation, I could make the graph and I could make the table. Yeah. All right. In this situation, we start off with the table. We did this, and then we wrote that. But you only need one of the three to produce the others. All right, let's take a look at some must-know words. First of all, the function table, in case you forgot, it's just this XY table we've got here. An ordered pair or coordinate pair, that's just these X and Y values that you can actually graph. All right, here's the third piece of the puzzle, or the second piece of the puzzle. Here's the graph, and here's the third piece of the puzzle. Here's the equation that goes with that. All right, let's take a look at three specific situations. We'll look at a situation where you start with a graph like we did, and you have to produce the other two. Then we'll look at where you start with an equation, and you have to produce the other two. And the third one is maybe the hardest. You'll start with a graph, and you have to produce a table and an equation. All right, here's the first situation. We're starting with just an XY table here, and let's pop the values in. And we have to graph the ordered pairs and write an equation. Well, let's start off with the graph, and that's pretty simple. We've got the XY values right here, 0, 1, 1, 2, and 2, 3. So let's go ahead and put those guys on there. 0, and then we're supposed to go up 1. Again, remember, you go over first. In this case, we didn't have to go over at all. Now we've got 1, 2, so we'll go over 1. Oops, go over 1, up 2. And the last one is over 2, up 3. You would not believe how hard it is to graph on top of this with your mouse. All right, stick the line on there, and that's pretty close. We've graphed that line. All right, now we have to write the equation. Well, what's the rule? Well, the rule is just whatever x is, and you add 1 to it. So if x here was 100, this would be 101. So that's what the y is equal to. Y is equal to whatever x is plus 1. And we've just done that. So now I'm going to give you a situation where I give you a table, and I'm going to ask you to graph it. And nothing as fancy as this. Just make an x and a y axis, and just kind of put the points approximately where they are. Just kind of air graph it, I call that. And then write an equation. Figure out what the rule is, and see if you can't write it as a y equals x statement. All right? Let's take a look at our first pause problem. Okay, see what you can do with this. All right, well, I cheated a little bit. I think I have my graph all put together here, so I'll just go drop this in. And I got 0, 3, so I'll just put that first point in, over 0, up 3, and the other points should line up. I'll just double check them. 1, 4, over 1, up 4, that looks good. And I skipped 2 just to show you that these x values don't need to be sequential. It doesn't matter. Put in 3, and there's my 6. Okay, so I've got that down, and what's happening? It looks like plus 3, right? So that just means the equation is y is equal to x plus 3. I'm betting you did that, and you realize that, yeah, this isn't as complicated as I thought. Okay, let's take a look at another situation. Now we have a situation where we're starting with the equation, and we have to make a table, and we have to graph it. All right, so what are we going to do here? Well, making a table is pretty simple. Just grab it here. We just make an XY table, and you get to pick the values. I like using 0, 1, 2. They're small numbers, which means the smaller the numbers, the easier it is to graph. So if I put 0 in here, if I substitute 0 for x, this is really what we're looking at. Y equals, it's going to be 2, and then you substitute it in instead of parentheses like this, 0 minus 1. Now, I'm not going to type them all out, but this is what you're really doing. So y is equal to 2 times 0, which is 0, minus 1. So this one's going to be minus 1. And then I could substitute this one in. Y is equal to 2 times 1, which is 2, minus 1. Well, that's just 1. And if I substitute the 2 in, 2 times 2 is 4, minus 1 is 3. So there, that was pretty, I mean, that's not going to hurt anybody making that table. So now we just graph it. We just put these numbers on, and I took some shortcuts to make it easier for us. 0, negative 1, so I'm over here at 0, and I go to negative 1 right here, and everything else should line up. Let me just check. Do I have 1, 1, over 1, up 1? I sure do. And do I have 2, 3, over 2, up 3? There you go. You started with an equation, and you were able to graph it and create the table. All right, now it's your turn to try that same thing. Here's your next pause problem. Go ahead and give it a shot. All right, let's do the table again first. I think that's probably easier. Oops, I got to find my table. There it is. Just open this up for you. I don't know if we need to look at the ordered pairs, but you can see I substitute everything in this time so you can get that visual cue. And now I just have to graph it. So my ordered pair is 0, 2. Get this guy in there. Go over 0. And go up 2. And then I'll just check to make sure that I got the right one here graphed. I got 2, 8, over 2, up to 8. That's good. And I got over 4, up 14. Yeah, that one looks pretty close. I had to error graph that one, so that's pretty doggone good. All right, there we go. Nice work. All right, now we just have to look at the third situation. The third situation is where you're given a line, and you then have to make a table and write the equation. This one may be a little bit harder, especially working here online, but let's just see if we can't figure this out. So this first point then looks like we go over 2 and we go up 1. So the y value here is going to be 1. And the next point looks like we go over 4 and up 2. So I click in my 2 point, and this other point looks like you go over to 6 and up 3. It looks like it's a half of what it is. So my guess is that if I had 100 here, it would be 50. And let's just see, what if it was 1? Well, if it was 1, it would be half of 1, which is a half. Let's see, over 1, up, it looks like a half. All right, so my equation is, I'm just going to move this. My equation is y is equal to x divided by 2. That's one way of thinking about it. Or y is equal to 1/2 x. These are the exact same things. A half of x or x divided by 2. They're the same things. All right, let's have you try one here. Get you set for your next pause problem. Same thing, quick. Read the points on the graph, make the table, write the equation. Okay, if you're struggling to read the points, I can give you the ordered pairs. It'll help you make your XY table. All right, well, here's your XY table. 0, 0, 1, 2, 2, 4. Really what's going on here is it's just times 2, right? So my equation is y equals 2x. Pretty straightforward. All right. Now, the next portion of it is about the y-intercept. And some people think that this is too hard for 6th graders. I don't. I actually think it makes a lot of sense. The y-intercept is where the line crosses the y-axis. So this is the y-axis. So wherever it crosses the line, whichever one of these points, it could be 5, 4, 3, 2, 1, 0, negative 1, negative 2, that's called the y-intercept. So this one here, this just crosses right here, right now at 0, 0. So whatever y is equal to, x is equal to. So look at over 1, up 1, 1, 1, sorry, I moved it. 2, 2, 3, 3, 4, 4. Okay, this one here, the y-intercept is at 1. You see where it is? See how it's just plus 1? We're just at 1 there. Here's the plus 1, and that shows where it crosses the y-axis. This one here is y is equal to x plus 2. Notice it crosses at 2. Okay? Now, even if this line were a different angle, let me just put a different angled line in here. Let's make it magenta. Actually, I don't know what magenta is, but we'll just put magenta in. I don't know. Even if it was this line right here, we don't know what x is. It's still going to be +1 because that's where it goes through the y-axis. This one is probably something like 2x + 1. Let's take a look at some more examples. Look at this one here. This one is y = x + 3 because look where it crosses the y-axis. Here's the +3 and it goes through at 0, 3. That's because when you put 0 in for x, you're going to have 0, 3 as your first point. Look at this guy's -1. And look at, here's the -1. So you start looking at these equations, y = -1, you go, hey, it's going to go through down here, -1. You already know 1 point. Look at this one. Here's -2. Y = x - 2. So this one we knew had to go through down here at -2. I think I got that right there. It's just a little low. Let's see if we can use what we learned about y-intercept to match these lines, these 6 lines with these 6 equations. All right, looking at this first one here. Well, it doesn't have a minus or a plus or anything. It goes right through 0, 0. So it's either got to be 2x, x, or half x. Well, now we got to look at some of the points. So we got the coordinates of the points, the x, y points. We got 1, 1, 2, 2, 3, 3. This one is pretty clearly that the y is equal to whatever the x is. All right, so let's look at the second one. What's the y-intercept? Well, here's the y-axis. This goes through at -2. Do we have any that have -2? No. -3, nothing. +3, -2. It's got to be this one here. And if you look at it, it's got the exact same slope to the line, y is equal to x, but it's just down here going through -2. This is just y = x - 2. How about this one? Well, this one is at 0, 1, 2, 3. The y-intercept is up here at 3. So that's got to be this one. Not -3, but +3. And again, look at all 3 of these lines are parallel. They just cross the y-axis at different points. So you got y = x, y = x - 2, and y = x + 3. All right, let's look down here. Now, these two look to be parallel. So let's take a look at this one. This one here is got to be either 2x or half x, because this one here has got to be -3. So we may as well just put it here. This has got to be -3 because this is a -3. So we've got these two left. Which one is 2x and which one is half x? Well, which one has a steeper slope? Well, this one does. This one looks like y = 2x. So let's just look at it. We go over 1, up 2. Over 2, up 4. So it looks like the y is always double what the x is. 1, 2, 2, 4. This is y = 2x. This one has to be a half x. So let's look at it. It's kind of the backwards one. Go over 2, up 1. So y is a half of whatever x is. All right. I think you guys are ready for your ticket to the show. All right. For your ticket to the show, I would like you to just go through and look at these tables here and complete this table. You've got a function up here. And go ahead and identify the coordinate pairs. Very simply. The next one here, I want you to determine what this equation is right here, what's underneath here, and make a quick graph of it. All right? All right. So make sure you write that equation in the y = x form. Okay? Yep. All right. Who is Stanley Kirk Burrell? It's MC Hammer. He wore these crazy pants into this song, You Can't Touch This. It was awesome. I was a child of the 80s. You guys are lucky I survived all the weird stuff that went on. But look at these babies. Yeah, how would you walk in those? But he had a cool dance to him. You guys probably don't recognize him. Your parents probably do. But you probably have seen him referenced in Super Bowl commercials and other Cheeto commercials. He's kind of the spokesman for Frito-Lay or Cheetos or whoever makes those. All right. Thanks for listening. Bye. Hey, welcome back. Hopefully you got those ticket to the show and pause problems figured out. All right, today let's just start off with 3.7a. We're going to work on just identifying and plotting the points and completing the tables. Tomorrow we'll put it all together. We'll be looking at equations and choosing the correct table based upon equation, based upon the line and things like that. But
baby step. Let's take a look at this first problem. You don't have to write anything down yet. I'll tell you when to write. All right. So this one here, we just have to look at y equals x. We have to complete the table, and we have to graph it. Well, put in three values, 0, 1, and 2. If x is 0, y is 0. X is 1, y is 1. If x is 2, y is 2, right? Because y is equal to x. Then we throw a graph on it, or a line on it, and on the graph, and there it is, just like that. Now, I want to be reasonable. I told you not to write yet, even though this is problem number 1. This is the way we're going to do this. Here's the graph, the table. I just want you to make a little XY graph like this. I call it air graphing, and just put the approximate position down. That would be about 0, 0. This would be about 1, 1. This would be about 2, 2. And take and grab a line and slap a line on there, you know. It doesn't have to be perfect, you know. I don't even have an arrow on this end, but that's okay. It's just an approximation of the graph. Okay, sound reasonable? All right, make sure you got that one down because that's number 1. Copy that one down. You do not need to copy the table for this one. You can just do the graph for it, okay? All right, sounds good. This next one, just take and make a quick little XY table like this. Put 3 values in, 0, 1, 2, and complete the table. And try graphing it. I'll give you a few seconds and I'll do it for you. Okay, here would be the table. When x is 0, y is 0. When x is 1, 2 times 1 is 2, y is 2, and so on. So let's just put these guys in here. I got 0, 0. I have got over 1 up 2. 1 up 2. I have got over 2 up 4. 2 up 4, just like that. Throw the line on there, and mine will be a little fancier because I got a grid, but hopefully you just got just like the little air graph. All right, let's take a look at another one. Go ahead and try this one. Okay, same thing. 0, 1, and 2. We put those values in. X is going to be 0, y is 0. X is 1, y is 3. Here it is. This is the 3x. See, I put the variable or the x value in parentheses there. So let's just graph these. Again, it's a 0, 0. And let's look at over 1 up 3, over 2 up 6. Here's 2 up 6. Slap a line on it. And that's pretty doggone good. All right. You with me still? Good. That was our third problem. Okay. Let's take a look at some observations here. Did you notice how the line kept getting steeper? Yeah. These values here, these are called the slope. This one here is just y is equal to x. All right. This one's going to go right through at a perfect 45-degree angle. So this can be called the slope of 1. It could be 1x equals 1y. But here it's y is equal to 2x. See how it's steeper? And here's 3x, and 4x would be even steeper, and 5x, and 6x, and so on. Okay? That's slope. The bigger that number with the x gets, the steeper the slope is. All right? Keep that in mind. Let's take a look at problem 4. Y equals 2x plus 1. See if you can graph that. Same thing, make a little xy chart. 0, 1, and 2 for your values. All right, here we go. Oh, I lost my lines. Let me throw them in quickly for you. Sorry about that. Okay, this one here, we're going to have 0, 1. This one here, we're going to have 1, 3. This one here is going to be 2, 5. And you can see the way I put the, I'm sure you didn't do all the work, but I typed it out so you can see how I got these, you know, see how you got the y value here. All right, so go ahead and click here, and I've already graphed it. So you notice the slope is a little bit steep, but it goes through here at 0, 1. It's not going through the origin anymore. Okay, let's try another one. Number 5, go ahead and graph this guy. Okay, complete the table. Got that. So we got 0, 2. 1, 4, 2, 6. Should have looked something like that. Good. All right, well, one more. Y equals 2x plus 3. Yeah, I know they're all 2x's. I've noticed that too. Okay. 0, 3, 1, 5, 2, 7. Go ahead and graph that. So now, did you notice anything? Did you notice that the slope, because they were all 2x, 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 all those lines are parallel. These are the lines. I've just put them on one graph. That's because the slope is always 2x. The only difference is where they went through the y-axis. This one's a little off. Sorry about that. Actually, they're all just a little bit off. I guess just those two. But this one, it went through at 0. This one here went through at 0. Sorry, because it was just plain 2x. This one here was going 2x plus 1. So that's going through right here. And this one's going through at 2x plus 2. So it's going through 0, 2. Sorry, everything shifts a little bit. Get out of there. Look at the lines here. Goes through at 0, 1 because it's plus 1. Goes through at 2 because it's plus 2. Goes through at 3 because it's plus 3. See the pattern? All right. There they are, all are together. All right, so last 3 problems, 7, 8, 9. Make a quick table. Graph them yourself. All right. 5x, that's going to be really super steep. It'll be something like that. Just a quick little air graph. This one, ooh, y-intercept of plus 4. So that's going to look something like this, you know. It's just a slope of 1, so let's see how it's kind of at a 45-degree angle going up there. And again, these are just quick little sketches of it. This one's xx plus 1. That's going to be even steeper than this one. If this is a slope of 5, this one is 6. It's even more steep. And it's a -1, so it's going through down here at -1. Okay? All right. Well, those are your guided problems. You are going to work through the skills, the worksheet 3.7 AB. I've attached it to this video. I want you to put it into Notability and work through it. You got 6 problems where you're going to do just exactly what I did here. You got a little equation, and you're going to pop the values in, which I already did for you. And then you didn't notice how I started taking things away. That's not a mistake. That's getting you to do the same thing. Just getting used to making a little XY chart with 0, 1, and 2 and popping it in. And then you have these graphs down here, which you need to complete the functions or complete the tables. Now, if it helps you to complete this middle portion, you can do it. Otherwise, you can just put the values over here. If you're going to do that, then you can just take and just put an X through there, so when I'm grading, it's easier to look at. I know some of these I had just 0, 1, 2. Others I had 1 through 4. Shaking things up a little bit. All right. Okay. If you want to get the answers to those, you can Google. There's a video on YouTube. Just do it. It's called Mini Lesson 3.7 AB. It'll take you through those and get you started on it. But I think you're in pretty good shape right now. All right.